Hello and a very warm welcome to you. If you're new to this channel, you won't have seen this picture before. If you've been watching my videos before this, then you'll probably be sick to the back teeth of this photo, but I'm not. I love it to bits. This real-world observation that anyone can make is impossible if the Earth is flat. So Earth cannot be flat. It's really as simple as that. Now, the video today is going to be dealing with this observation, which I made, and in particular dealing with another person who is active on YouTube, certainly in comment sections, doesn't make many videos, and he's commented on my video and he tried to come up with an explanation based on a flat Earth for this particular observation. So just in case anybody is new to the story, let's quickly run through this observation and why it is impossible to take this on a flat Earth. I was on top of Traprain Law, a hill in East Lothian in Scotland. The tower on the left is on top of a hill called Byers Hill, and the total height to the top of the tower is 210 metres above sea level. The tower is about 8.2 kilometres from my location. This means that if we draw a line across the screen that is level with the top of the monument and perpendicular to the monument, we know that because my camera was angled slightly downwards towards the top of the monument, that any object further away than the Hopetoun monument that is 210 metres or taller above sea level, or higher above sea level, must appear in our image above the red dotted line. The hills in the distance were identified on Peak Finder and confirmed and are all around 1,000 meters tall. They all fall below the line. The peak of each of those hills falls below the line and well below the line in the case of Ben Arnain and Ben Eam. And that is impossible if the Earth is flat. There should be a major portion of those hills above the line. This can be confirmed by looking at a computer model of the same observation. So we have the observation at the top. It's just been cropped to make it fit. And at the bottom here are stills taken from Walter Bislin's curvature calculator model, where you can compare what happens on a flat Earth and what happens on a globe Earth, or what is predicted to happen. The flat Earth model, the tower height and combined tower and hill height here are represented by this red and yellow rod. So we draw a line, dotted line across the screen, level with the top of that rod. And the hills are represented by the grey shape, it's supposed to be like a mountain. And we see that the flat Earth model prediction is that the hills should all be well above the line, with only a small portion of each hill falling below the line. The globe Earth model or spherical Earth model predicts exactly what we actually observe. Again, the red dotted line is drawn across the top of the height of the Hopetoun monument and Byers Hill. Ben Lomond almost touches that line, just as we see here. Ben Arnain is significantly below the line, and the peak of Ben Eam is a little bit higher than the peak of Ben Arnain, but still significantly below the line. So Real-world observation matches globe Earth model predictions and is completely different to flat Earth model predictions. So my assertion that this image is impossible to take on a flat Earth is supported by the computer modeling. And we can also test the assertion that anything above 210 meters or 210 meters or taller that is further away from the camera than the Hopeton monument should be above the line. We can test that using objects over smaller scales on flat surfaces. So here I've lined up some soda cans. We have a flat and level floor confirmed by a laser pointer, and you can see the camera is level with the top of the bottom can in the foreground, and all the other cans line up with their tops exactly level with the can in the foreground. The taller, if you like, the can above, it always appears above the line and never falls below that line. It's impossible for it to fall below the line with the camera level with the top of this can. Obviously, as they're further away from the camera, the heights of the cans gets smaller in our field of view. This is perspective and is accounted for in Walter Bislin's model and demonstrated clearly here. If you don't like this short scale 10 meters or so demonstration, then what about one over about 80 meters? Here we have the camera at the same height as the top of the hurdle in the foreground here. The hurdle's actually some distance from the camera. It's not very close to the camera. But you can see that the other hurdles that are much further away from the camera, that are the same height as this hurdle that's closest to the camera, all the tops of those hurdles all fall on the line. A taller hurdle and other things that are taller than these hurdles, for example the trolley handle or this mat or the high jump pit stands, these all fall above, come above the line. In this particular example, I've shown what happens if the camera is below the height of the foreground object. So I've moved the camera to a lower elevation than the hurdle in the foreground, and now more distant objects that are taller than this hurdle can fall below the line. But this is only when the camera is below the object in the foreground. My camera was at 221 meters and the Hopeton monument is at 210 meters. So my camera was higher at a higher elevation than the object in the foreground. What happens when you put the camera a little bit higher than the object in the foreground? Well, objects the same height as the hurdle in the foreground here actually start to appear above the line, never below the line. So this hurdle in the background here is the same height as the hurdle in the foreground, and yet it appears well above the line, as of course do all objects that are taller than the hurdle in the foreground. So my assertion that on a flat Earth, any object that is 210 meters above sea level or higher above sea level than that must appear above the red dotted line drawn across the screen. This assertion is not just a baseless assertion, it is backed up by tested demonstrations using objects on flat surfaces. It's backed up by computer modeling of what is predicted on a flat Earth and what is predicted on a spherical Earth. So that's the nature of the observation. Now I want to go on to talk about Gleem's drawing and Gleem's attempt to explain this observation in terms of a flat Earth. So let's get to Gleem's comment. I've tried to record this once already and it went on for ages. So I'm just going to try and get through this as quickly as I can to illustrate how Gleem has got pretty much everything in this comment wrong. I've copied Gleem's comment into Word, I've left his words in black, and I've interjected with some red. I'm not going to try and do two different voices, so I'll try and remember to explain whether I'm quoting Gleem or whether I'm responding to Gleem. Gleem says, "Miles Davis, you should have dropped me a message saying you were doing this." He means making a video about his diagram. My response is, why? Do I need your permission to make a video? He says, "It must have got your back up on Jose's the other day, as you did not make any mention of this live." So I did interact with Gleem on Jose J.G. Gonzalez's channel live hangout, and it was about a completely different subject. It did prompt me to have a look at his diagram again and to restart the project, making a little video about it, which I had started over a year ago and decided it wasn't worth the time or effort at that point. So as I say here, it didn't really get my back up. We were talking about Soundley's photo of Pontchartrain Causeway, nothing to do with my photo, but your complete lack of intellectual honesty or intellectual ability did cause me to reactivate a project I had started some time ago about your drawing. Gleem continues, "Ah, well, looks like you actually went back as you thought, no, I can't let him have a point. How can I word this so it makes him look wrong?" Well, apart from the fact that you've put that in quotation marks, and I've never said that, I don't need to word anything to make you look wrong, Gleem. Not about this anyway, or about the Pontchartrain Causeway. You simply are wrong on both fronts. So Gleem then makes a series of points, and they do ramble on a bit at times, but we'll see how we get on. He starts, "Let's go. Number one, a flat earther called Gleem," is a quotation from me in my video. And Gleem says, "who is in fact a Mac earther and not a flat earther." My response to that is to say you may identify as a flat earther, but you do argue flat earth talking points all the time. You examine evidence that proves Earth is not flat, e.g. Soundley's photos and my photos, and try to argue that the same observation could be made on a flat Earth. In order to argue this, you have to reject known physics without providing any alternative, and you sometimes pull numbers and ideas out of fresh air, and you do the equivalent of arguing that black is white. He says, "But hey, don't worry about the domain name or paying attention to anything I say on Hangouts." And he posts a link to his diagram. This link, if I haven't shown Gleem's diagram yet, this is Gleem's diagram. And it does have the domain name Mac Earth, which completely escaped me to start with. I didn't notice it, and even if I had, I wouldn't have known what it means. But I say here, I admit that I am often guilty of ignoring things you say on Hangouts, because to be quite frank, you usually make about as much sense as a random word generator. The word salad comment I'm going through right now being a pretty good example. You can call yourself a Mac earther if you like. I've no idea, still no idea what he means by Mac earther. But if you argue that flat Earth makes as much sense as globe Earth, in my world that makes you a flat Earth apologist or a globe denier, and that's pretty much the same as a flat earther. You're at very least giving flat Earth equal credibility when it deserves zero credibility. Gleem's point number 2. Timestamp and a quote from my video, which he doesn't close the quotation marks, but I assume is the first sentence. past them too, and it goes to the base of Ben Lomond, question mark, question mark, question mark. I thought it was a straight line of sight, meaning you should not be pointing at the base of anything unless you are angling the camera down. This is quite an important point, so let's be clear about it. My response is, so you clearly haven't even bothered to watch my video, or take note of the camera location and elevation. Let me remind you, the camera was at 221 meters on top of Traprain Law. The Hopetoun Monument is 210 meters at the top. This means the camera was pointed slightly down. Over the distance of 125 kilometers to Ben Lomond or 137 to Ben Eam, that slight downward angle would result in the line of sight. It's still a straight line of sight, whether it's pointing down or up, being to the base of those mountains, if it were possible to see through the various obstructions on the way. The fact that the camera was pointing down is the whole point of the observation. Had the camera been at 210 meters, it could be argued that a small error in measurement of that elevation would result in the camera pointing slightly upwards. And this could perhaps explain the observation. Let's have a quick look at my pictures of hurdles to explain this to you. Yet again. In this picture, the camera is at the same height as the top of this hurdle. So the center of the lens is positioned at the same height as the top of the hurdle in the foreground. All the other hurdles in the picture that are the same height as this hurdle have their tops touching that red line across the screen. Anything that is taller than that hurdle in the foreground appears above that red line across the screen, and things that are smaller appear below that line across the screen. If the camera were lower than the height of the front hurdle, as in this demonstration, then the hurdles that are the same height and even a hurdle that is taller than the one in the foreground can appear to be lower or shorter in the picture. And that is why I took great care to make sure that my camera could not possibly be lower than the Hopetoun Monument. In fact, it was slightly higher than the Hopetoun Monument, which means that the situation in my observation resembled this more than the previous two pictures of the hurdles. Here we have the camera above the height of the hurdle in the foreground, and all the hurdles, the ones that are the same height and the taller one, appear above the red line, just as they're predicted to do on this flat surface of an indoor athletics track. Hopefully, you get it now, Gleem. He continues with this point to say, if you remember, I identified that you also had a 2-degree tilt to your left as the lowest tower is tilted, of which you agreed and did not clarify you had leveled your tripod. Once again, a bit of jumbling up of words in the sentence there, so it doesn't make a great deal of sense, but I know what he's trying to say, and he's wrong. And I can show evidence that he is wrong. This is the picture we are talking about. I have drawn a perfectly vertical line on this picture going down through the center of the Hopetoun Monument. There is no sign of any tilt at all. Certainly not a 2-degree tilt. I can show you what a 2-degree tilt would look like. This is what a 2-degree tilt would look like on the picture. You can see that the line now starts in the middle of the monument, but at the base it has gone way over to the left. However, there is no 2-degree tilt in the picture as it is presented on screen. So once again, Gleem is completely wrong. His comment point number 2 continues, and I confirmed to you and showed you the maths in your photo where your red dotted line is the wrong horizon line. My response to this is to say, I have lost count of the number of times you have been told that it is not a horizon line. Since you don't seem to be able to grasp even the simple concept that I have explained using the soda cans and hurdles, I really don't know why I'm bothering to talk to you at all. I'm about to continue with probably half an hour or more of going through each point, and you can't even grasp the simple concept. I've shown you the pictures of the hurdles. Please go back and look at that video again. Look at the soda can pictures, look at the hurdles, and understand what you are being shown. His point continues, as you forget to reduce the field of view past the monument. And my reply, the field of view past the monument is exactly what is seen in the photograph. The photograph shows what the camera captured. It shows the camera's field of view at that level of zoom. That's it. There's no need to reduce anything. We are asking the question, can this picture be taken on a flat Earth? And as I've demonstrated, it most definitely cannot be taken on a flat Earth. So Earth isn't flat. Gleem's point number 3. And he now goes on to basically trying to poke fun at me, I guess, and criticize me for forgetting things and so on, which is just daft, but never mind. He quotes me saying this one is a bit closer to being accurate. I was referring to, I'd used a diagram for purely diagrammatic purposes, not intended to be a scale diagram, but simply to show in a diagram the various lines of sight and sizes of objects, or how objects would appear. He says, ha ha ha, you mean to tell me that you do not remember making a video yourself and saying you have to use 2 different scales for the horizontal and vertical as it does not fit on your screen? Well, of course I remember. And I remember explaining in another video that I had drawn a correct scale diagram, but using different vertical and horizontal scales to make it easier to see. In the current video and in others I have made, I have used scale diagrams in which the same scale is used for vertical and horizontal scales. However, this makes Traprane law almost impossible to see on the screen. And just to remind you of what that looks like, this is what it looks like. So shown like this, you can barely see Traprane law of a Hopeton monument as they are represented on the screen. If we project it up to a full screen, I hope that you can see the little triangle and the little rectangle, which are copied here. And if we apply a bit of zoom to those, they do just about become visible on the screen. But they're very small and it's difficult to make things out, and even at this scale I can't get Benim onto the picture, and we'll talk about that a little bit later. He says, ha ha ha, wow, you forget so much. I haven't forgotten it, Gleem. I know exactly what I've done and why I've done it. Gleem's point number 4, again quoting me, saying Gleem has taken a photograph, and he says, nope, I have a scanner which scans it to an A4 image. Well, my response, okay, but my point is still valid. When I place your drawing on my computer screen, the dimensions of the drawing on screen do not match the dimensions of the original drawing on paper. So I cannot just place a ruler on the screen and measure it and compare the measurement that I get with the data that you provide later in point 6. That's the point I was trying to make. However, the relative dimensions of the various parts of your diagram will remain the same. So if something is twice the length of something else, that it will appear twice the length on my computer screen, just as it does in your drawing. So if you had really used the scale that you claimed of 2 millimeters to 1,000 meters, just to remind you, Gleem is claiming that this is a scale diagram here. He's not saying, I've written a scale here, but I didn't bother using it. Then the 125 kilometers should be 15.24 times longer than the 8.2 kilometers to the Hope to Monument. And what I'm referring to here is saying the distance from Ben Lomond here to the observer is 125 kilometers in reality. The distance from the Hope to Monument to the observer is 8.2 kilometers. So this distance should be 15 times smaller than this distance, and yet it's actually more than, it's shown more than halfway. Instead of being right back here somewhere, it's shown more than halfway to the distance to Ben Lomond. It makes no sense. It's just daft. Your drawing is not to scale, yet you have written a scale on the drawing. Why? Why write you've used a scale when you haven't? Point number 5. He quotes me saying, what happened to Benim? I was asking why Benim was not included in his diagram, seeing as it is part of my original observation. And he says, ha ha ha, right after you just showed, in quotation marks, I cannot fit it on the screen either. Ha ha ha. Wow. Well, Gleem, the point being made here is that you seem to have placed Ben Lomond and Ben Narnain at completely random locations in the drawing. Actually, it turns out they don't think they are completely random locations. He's just got the position of the Hope to Monument completely wrong. So I wonder why Benim was not shown. Now, there's a perfectly valid reason why Benim was not shown on the screen in my presentation, and I can show you now exactly where Benim is in my scale diagram. We've already seen it, but here it is. But there is no good reason why Benim should not be in your diagram. The distance from Ben Lomond to Ben Narnain is 10 kilometers. Benim is only 2 kilometers further away from the camera than Ben Narnain, and so it should be here somewhere. There's plenty of room to fit it on the diagram. So why didn't you bother to include it? Let's go to point number 6, because this is the big one. I've made a small video about this already, but I'll still go into the same detail here, just for anybody who hasn't seen that other video. So Gleem says, with the timestamp, he quotes me saying, let's see if we can figure out the percentage and scale. The point I was making is I don't know what these percentages refer to, and the scale didn't seem to make sense, and I was trying to figure out how he'd used the scale. Gleem says, here is the data table I gave you last time, and it was fully explained to you. Well, the data table is a bit difficult to read in the comment section or in this Word document, but I've transferred all the data to Excel, I believe accurately. And here it is. And Gleem has, I've put Gleem's figures in black and my figures are in red. The distance, observer distance to Traprain Law is correct. The height of Traprain Law, Gleem has 210 meters, it's actually 221. First mistake. Distance to Hopeton Monument is correct. Height of Hopeton Monument, Gleem has 250 meters, it's actually 210 meters. Distance to Ben Lomond, Gleem has 12,460 meters, it is 125 kilometers away, or 124.6 kilometers away. I rounded it up. That is 125,000 meters. Okay, 1 kilometer is 1,000 meters. So he's out by a factor of 10. He's out by a factor of 10 in Ben Narnain. He's out by a factor of 10 with Ben Eam. He then calculates angular size. He gets an angular size which is incorrect for the Hopeton Monument. I'm assuming this is degrees. I've calculated in radians and in degrees. He's probably wrong because of using a 250 here instead of 210. This is relatively close in terms of degrees. But because his distances here are out by a factor of 10, and now his angular sizes are also out by around a factor of 10. I get slightly different figures, but they're not much different. But they're out by a factor of 10, or Gleem's are out by a factor of 10. Quite an important mistake. I'll ignore the next two columns for the moment, or the next three columns for the moment, and have a little look at the last two. This one, which is entitled Scaled Distance Centimeters. Now, I've made an assumption here that he is referring to the scale mentioned on his diagram of 2 millimeters equaling 1,000 meters. I've put a question mark there just in case I've got that wrong. If he was using that scale, then the scaled distance in centimeters would be correct for the three hills in the distance, the three mountains. But he has made a tenfold error in calculating the scale for the distance to the Hopeton Monument. I'm not quite sure how he's got these correct, given that he's made an error here as well. But never mind. So precisely how Gleem has managed to get the correct values here, in spite of using the wrong values here, I don't understand, and he's got the wrong value here in spite of using the correct value here. But hey ho, Gleem is wrong again. Scaled height times 2, as given in the last column. Quite why he'd want to multiply the height by 2, I'm not certain, unless perhaps that was, no, I can't work out why, but hey ho, never mind. He's got 3 of the 4 correct, and the fourth one is wrong because he used the initial value of 250 instead of 210. Now let's look at the 3 columns here in the middle. He has a distance to the horizon. He has something he calls Hori Deg Dip, which I assume means the dip to the horizon in degrees. And he has refracted drop. This distance is about right for observer height of 210 meters, or 221 meters, be a bit different, but not much. The dip I think is about right. I honestly haven't checked it. Why bother with spherical Earth horizon and dip values when you're supposed to be trying to explain my observation in terms of a flat Earth? Did you use these figures in your diagram? I can't see where you would have used them, but yeah, it makes no sense. The same applies to refracted drop, but I think it's worth pointing out here that he's got refracted drop completely wrong. I'm assuming his units here are meters. Now, the refracted drop to the Hopeton Monument is about 4.6 meters, and he's got that right. But to Ben Lomond, the refracted drop is just over 1 kilometre, and he has 11.4 meters. The drop to Ben Narnain is 1.2 kilometres, over 1.2 kilometres. You have 12 meters. And to Benim is 1.26 kilometres, and he has 12.6 meters. I'm not sure whether he used these figures in his diagram or not, but if he did, they're wrong. And even if he didn't, they're still wrong. So, Gleem, you got all your figures, virtually all your figures for this table wrong. And I'm still struggling to see how you use them. I don't remember looking at this table before. You may have sent it to me in a comment, but as I said, your comments have a tendency to be long and almost always completely wrong. And it was already clear to me that your drawing was complete fantasy. So I may well have ignored your attempts to explain it, or looked at these figures at the time and thought, well, they're wrong, so what's the point? Apologies for not taking it more seriously at the time. But if you do want something to be taken seriously, it does help if you make a little effort to get everything correct first. Point number 7, he quotes me saying in my video, I wonder where he got the 25 degrees and 30 degrees from. And he tells me it was on a health and safety PDF for the Hong Kong government. If you would have paid attention last time, comma, here this may jog your ever-failing memory. Okay, so he provides a link to the relevant document, which is this one, showing the field of view of the human eye, the vertical field of view. The figures he's used are for maximum eye rotation, so that's when you use your eyeballs only to look up or down. The field of view that you can perceive accurately is much smaller than that. Why he would use those figures for these angles here in his diagram is beyond me. As I say here, okay, you do realize that the picture is a still taken from a video filmed with a camera. And that camera was zoomed in I think about 40 times. That's the maximum optical zoom. It might have been less. I can't remember off the top of my head. I haven't gone to check. The field of view of the human eye is completely irrelevant. What matters here is only what's in the picture, in the photograph, in the still from the video. That field of view matters, and that was the field of view the camera had at that particular point in time. And there's no debate about what the field of view was, because that field of view is captured in the photograph. Why use field of view for the human eye to do a scale diagram for a photograph? Makes no sense, Gleem. You're wrong again, Gleem. Here's point number 8. He quotes me saying, why is it, he says at 100%, I think I said, why is it 100% there? And he says, because people who know about perspective understand there is this thing called circle of view, which is where your photo edges are. Again, I showed you this at the time and you ignored it then, and he posts yet another link to yet another document that is completely irrelevant as far as I can tell. Here is the picture that he refers to. And it does seem to show here a square view within some sort of circle. It refers to the visual cone. No circle of view mentioned. And it shows how the lines A, B, C, and D here would appear to an observer looking at them. Well, it doesn't actually show D, I don't think. But that's all very well, but has nothing to do with the observation that we're talking about, or how a camera actually works, although it will capture the image in a similar sort of way. My response is to say, okay, once again, please understand you're looking at a still from a video that was shot at about 40 times zoom. So since your angles of 25 degrees and 30 degrees are completely wrong, so is your 100%. But also, how did you decide the distance from the camera that you would call 100%? It seems pretty arbitrary to me. And since you haven't used any correct scaling, the whole point is somewhat moot anyway. But just to go back to why this point in the field of view is considered to be 100%. Agreed, this is the point at which this field of view angle, the ground appears, in the observation, or the point at which that line meets where the ground is. But there's no reason why this line can't continue, and 100% could be from here down to the ground, or even from here down to the ground at an angle. This hasn't been explained, and it really doesn't make a lot of sense. We know the field of view, we know the uppermost point of the field of view and the lowermost point of the field of view. It was zoomed in considerably. This diagram, once again, makes no, just is irrelevant to the observation it's purporting to describe. Here's point number 9. Well, it does appear to rise up in front of you. That's a quote from me. And he says, wow, you've changed your story. Even on your original video, you said, bullshit, it does not appear to rise up. This is hilarious. Well, I don't think I've ever said that the ground does not appear to rise up. I see things the same way as anybody else does. When I look at something, for example, when I was looking along this athletics track, I saw the athletics track appear to rise up in my field of view in the same way that it does for the camera here. This is not an issue for me. Why Gleem should think that it is an issue for me, I don't know. What I have said, and what Gleem perhaps doesn't really understand, is that it doesn't actually rise up. And so when you are trying to depict what is actually happening in the observation, you need to stick with what is actually happening and not how it is perceived by the eye, or by the camera, if you like. I never said, he says that he never said it really happens in reality. And okay, that's the point I've just made. So if it doesn't actually rise up in reality, why should it rise up in your drawing, which is supposedly a drawing of reality? The only view from which you need to show it rising up is the same view that the photograph actually takes. So when you're looking at something head on, straight on, pardon me, then yes, you see the floor rising up. The same applies in the original observation. That's an example of it. This is why this red line is positioned here. If the Earth was flat, the floor, if you like, of the Earth should continue to rise up in our field of view towards or even perhaps going beyond this line. The fact that it doesn't, the fact that these mountains are below that line is evidence that the Earth is not flat. But this straight on view is the view for which we need to take into account the fact that the floor appears to rise up. This seems to be completely lost on Gleem. He goes on to say this is merging, I think he's referring to his diagram, this is merging an orthographic view with a perspective view, just like these PhD holders in optometry, and he lists this paper. So he's claiming that other people mix up the orthographic view and the straight-on perspective view, if you like. Well, I don't think he's right about that either. Let's have a look at the paper in question. So this paper is actually in a psychology journal and is investigating the ability of people to judge distance on a flat surface, on a surface that's sloping up, going away from them, and a surface that's going down, sloping away from them. And they're only interested in the human perception of distance in that situation. Now, there is a diagram in here which is referring to this, the perceived ground from the side and the perceived distance, and using this to explain why the perceived distance is shorter than the real distance to an object. So this represents the real situation, and this represents the perception by the subject. I haven't read this paper in colossal detail, but I've read enough of it to know what's going on. They show here a more inclined surface, further changing the perceived distance of the object. And in the graphs that they show of their data, this is probably the best example. These are either on horizontal or sloping surfaces. So the top ones, A and D, are on horizontal ground, and the perceived distance as opposed to the reference is gets progressively worse the further away the subject is from the object, and that doesn't change if it's an uphill slope or whether the slope is greater or less. This paper is utterly irrelevant, and these drawings that are in the paper that show the perceived ground rising up are there for illustration purposes only. They are not in any way trying to describe reality. They are trying to describe why the a human being perceiving something doesn't make a good judgment of distance. So once again, Gleem has used something that is completely irrelevant to to the subject. As I say here, Galinsky's equation is irrelevant since we are looking at a photograph. Galinsky's work was to do with how people perceive the world, and the same with the people who did this paper, where they applied Galinsky's equation to perception of distance and found that it gave a good correlation. So Gleem is wrong to try and merge the orthographic and perspective views. Here's point number 10. He quotes me saying, "It's not very well explained," and then says, "Well, maybe listen the first time. I wrote walls of text explaining it all, instead of just calling me names and leaving it for a year and then coming back with your amnesia-ridden memory." Well, I don't think I called you names, Gleem. If I have, then I apologize, because I don't think that's a very productive thing to do. Sometimes people do frustrate and annoy me enough that I do call them names. But saying I've got an amnesia-ridden memory is a little unfair. Everybody forgets things, and I don't mind admitting that I may have forgotten some of the things that we discussed previously. But it's your diagram, if it really is a good diagram to explain my observation, should contain enough information that someone looking at it can work out what it's about, and it doesn't. I say, yes, you wrote walls of text, none of which made any more sense than the wall of text you've posted here. I've already shown that you've got just about everything wrong in this drawing. So it doesn't matter how much time and text you spent explaining it. If your drawing is based on the wrong numbers, it won't make any sense. Here's point number 11. Quoting me saying, "This is the best effort I received. I asked flat earthers and others to explain my observation in terms of a flat earth. And I do have to admit that the one I got from Gleem was the only one that made even a half-assed attempt at explaining anything. And as we've seen, Gleem's was rubbish." Gleem continues, "Yet at the start it was the only one you received, and back then you did not counter any of the points I made. You just called me names and run off for a year." No, I didn't call you names, or at least I don't recall calling you names. I may well have criticised what you said, and I may well have been put off engaging in a proper discussion with you on the basis that A, your scale diagram clearly wasn't a scale diagram, and B, you couldn't seem to be able to explain anything about it in a way that made any sense to me. He rambles on about another little argument we had about Lawrence Krauss, who made a statement in an interview that was a non-scientific interview made to lay people. And he made a statement, we defied gravity, I guess, or by having buoyancy, I guess. And Gleem got all upset by the fact that Lawrence Krauss had to guess about buoyancy. It was an offhand comment in an interview to a non-scientific magazine. Why on earth would you get worked up about such a thing? I pointed out your error at the time, and yeah, it's to bring it up now, irrelevant. As I said, I got one or two other less realistic efforts at explaining my observation. Even worse than Gleem's. Can you believe that? And yes, I've waited over a year, and yours is still the best effort that anyone has made. The globe model fits the observation perfectly within reasonable error limits. And not a single flat earther or anyone else has produced anything that even comes close to a flat earth explanation. You might want to ask yourself why that is. I will add here that I know that F.E. Core, I know that Nathan Oakley and his buddies have looked at this. F.E. Core has looked at it. I know that other flat earthers have looked at it, and not a single one has come up with an explanation at all. Gleam's maybe the best I've received, but it is complete and utter nonsense. Those other flat earthers, FE Core, even bothered to send me an email saying they would not be responding to my observation because they didn't like responding to observations. Why not? It proves the Earth isn't flat, boys. Gleam's point number 12, and this one goes on a bit, so I'm sorry, this video is going to get even longer. He quotes me saying, it's not possible on a flat Earth. And then Gleam says, right after not understanding my diagram and getting loads wrong. I'm sorry, Gleam, it's you that got things wrong, including the dimensions you used in your diagram, and forgetting all I have previously explained a year ago. Well, I may have forgotten some things, but I haven't forgotten most of it, and I was absolutely correct to reject your diagram back then. He says, well done, bro. One thing you forgot, though, is the actual scale-to-scale Excel analysis I'd done when you switched to showing the Cairnock Hill one. That when you account for the apparent rise in floor like PhD holders in optometry do, then you get the same result on a flat Earth. Now, we've seen that the optometry reference is nonsense. They are not doing anything even remotely like what Gleam seems to think. And he's now switched to challenging a different observation of mine, not the one at hand. And this is typical of Gleam. He will continually sort of pile up. He writes, by his own admission, walls of text. He gives loads and loads of links, which often mean his comments get filtered out by the spam filter on YouTube, which means they don't get seen as part of the ongoing discussion, and they can then be ignored for a period of time simply because they're not being read. But let's have a look at this very, very quickly, because this particular example is revealing. Gleam has placed the base of these triangles represent the appropriate angular sizes for the hills in the background on this observation. This observation is made from 210 meters, with this bridge tower here also being 210 meters above sea level, and therefore anything 210 meters or taller should appear above the line on a flat Earth. Now, Gleam has, or somebody else has calculated the appropriate angular sizes for these hills and has then placed them where they would like the base of those hills to be in order to fit with my observation. What they've used as their line is the base of the bridge tower, which they have estimated to be here. The bridge tower is considerably closer than the hills in the background. It's 45 kilometers away, and the closest hill in the background is 90 kilometers away. So it's half the distance. When you look on a flat surface, as Gleam has been pointing out all along, the floor appears to rise up in front of you. And therefore, the base of these hills will be considerably higher up in the frame, in the field of view, than the base of the bridge tower. And yet, even doing this, those angular sizes don't match those observed. Earl's Seat, well above the line, the actual location of top of Earl's Seat, which is on the line here. Dunbrack, a little bit above the line when it should be on the line. And Strong End, also a little bit above the line when it should be on the line. The correct location for the base of these triangles is about halfway up this bridge tower. The correct location on a flat Earth for the top of these triangles is way up here somewhere. And this can be shown by modelling properly on a flat Earth and not using completely incorrect modelling, which is what Gleam has attempted to do here. Gleem, my dear fellow, in that picture you've just moved the horizon line, i.e. the baseline for those hills, to a much lower location in the field of view. You attempt to justify this, I believe, but what justification I've seen makes no sense. I have a video showing the correct use of angular size for a flat and globe Earth for the Carnock Hill observation, which neither you nor anyone else has been able to show is not correct. So go find that video and show me where I've gone wrong. And even your arbitrary moving of that horizon or that baseline does not match well with reality, as I've just shown you. Can I really be bothered finishing this? Gleem goes on, and let's forget that I showed you that your footage has magnification and or compression in it here. Next picture. So Gleem takes pictures of the Hopeton Monument taken from a completely different angle with completely different equipment on a completely different day, and he wants to try to claim that this is in some way compressed and distorted. At the base of the Hopeton Monument here, because this is in silhouette, because he's chosen a picture from yet another observation, the base of the Hopeton Monument is somewhere down here. You can't see the base of the Hopeton Monument in the pictures that he's showing, so there is absolutely no way to line these up and show any distortion. It's also worth pointing out that these are my pictures are still frames from a video. I was panning the camera around. I hadn't at the time realized that these mountains in the background were going to provide me with a fantastic observation, because at that point in time I didn't even know the height of the Hopeton Monument. Once I found that out later, I went back and was able to capture these images by taking still frames, but because the camera is panning, this is slightly blurred here. It's impossible to come to the conclusion that Gleem comes to, that the image is distorted or compressed. He continues, and let's forget I showed you a full breakdown of what you did on the left and what you should have done on the right. And he posts another picture, and I say I have absolutely no idea what this diagram is supposed to show. The diagram in question is this one, and I've looked at it, and he seems to think that the center of the picture is in some ways something important. It clearly isn't. The observation that I show here matches perfectly with what a globe Earth predicts and is totally contrary to what a flat Earth predicts. And Gleem can draw all the lines he wants all over these pictures. He's not going to change that particular fact. And if he can't actually explain exactly what all these lines are in a clear and concise way, why should I be bothered trying to work out what on earth he means? He goes on, and of course, let's forget about me stumping you with this giant girl who is taller than the massive trees in the background. Gleem, there is nothing about this that stumped me. I told you at the time. The giant girl only appears giant compared to the trees because of the location of the camera. Go and look at the part of my video with the hurdles if you still don't understand this. We've been over this 2 or 3 times in this video already. I mentioned it in my videos before. You seem completely oblivious to the idea. Just for the people who are still listening to this ongoing saga, here is the picture Gleem is talking about. The camera is below the height of the top of the little girl's head. And for that reason, the trees in the background can appear below the top of her head in exactly the same way as in my hurdles demonstration. When I move the camera to a position below the height of the hurdle in the foreground, the taller hurdle in the background falls below this line. This is completely opposite to my observation, in which the camera was above the hurdle in the foreground or above the Hopeton Monument, and therefore things in the background that are the same size as the Hopeton Monument or taller must appear above the line. Get it through your thick head, Gleem. You have got to be able to understand this. It is simple geometry. And he goes on, and let's forget you chose the wrong horizon line in the first place, and posts another couple of pictures. I think these are of the Cairnock Hill observation again. Not quite sure where that picture's gone. Oh, there it is. Okay. And it's showing his triangles, and he's claiming incorrect application of horizon line, when in fact I've used exactly the right horizon line in any video that I've done. I'm not sure that I used it for this particular observation. I used the one from the Hopetoun Monument, where I can see the base of this tower, and I can also see a reference point in the distance that tells me where a spherical Earth horizon should actually be, if there was no land in the way here, if it was all water in the background. So Gleem's got that wrong as well, and he goes on, let's just forget it all and concentrate on the hand draw. Out of scale because it has to be. And you said you could not scale either. Well, no, I have not said I can't scale it, and I have scaled it, and you claimed to have scaled it. You claimed that this was a scale drawing. You put the scale on the drawing. He says, just like your Geronism video and in this video, whatever that's supposed to mean, more word salad, I'm afraid. Yeah, that would be much better for you. What would be better for me? And he then goes on to be more insulting. When you have rebooted your memory, let me know so I can go through this with you instead of waiting a year for you to actually listen to me. As you know, I had Alkay by the balls with my Photoshop analysis. Here is a more up-to-date version which will expose your own lack of knowledge of how your eyes work. And he's referring there to the discussion I had with him on Jose J.G. Gonzalez's channel about analysis of Soundley's photograph of Lake Pontchartrain Causeway. He was wrong in that particular analysis. He did not a bad effort in Photoshop of actually doing something, but he then managed to completely misunderstand what even he had done, whilst he was busy trying to criticize what someone else had done. So in conclusion, Gleem, I'll show you this PDF before I read that last little bit. Here we go. This is a PDF by Gleem, The Way of Intercepting Perspective. And we have a little cartoon Gleem there, and he goes through a number of things, some of which is actually sort of reasonable, and some of which I think misunderstands things, because he tries to use these diagrams from the paper, which, as I've shown, are only there to show how a human mind perceives distance when looking at objects that are far away. And this, of course, has nothing to do with what we were doing in my observation, because the distances to the objects in the background, we're not trying to estimate those distances. We know those distances. We're talking about where they appear in the vertical field of view, and we're using geometry to know where they should be. And so what we're interested in is where the real flaw is, and not this perceived flaw. Gleem, I'm a research biologist with over 30 years of experience and many publications to my name. I understand how eyes work quite well. I also understand that I was using a camera, not my eyes, although my eyes observed a very similar picture to the one the camera captured, although my eyes don't have 40 times zoom function, so it wasn't so clear as on the camera. The camera captured a 2D image on a flat sensor. So if you're going to go to the point that the eyes are curved and this makes a difference and so on, forget it. The camera isn't curved. I also have an okay working knowledge of physics, how light works and how lenses work. I'm not a physicist. I don't claim to be a physicist, and some of physics confuses the heck out of me, I am quite happy to admit. But optics and lenses, I'm kind of okay with. I've used microscopes a great deal in my work as a biologist. How people perceive the world, i.e., how the brain creates images using data received from the eyes, is still completely unknown. Nobody knows how we manage to generate this image that we see in front of us of the world. This conscious perception of the world around us is an absolute mystery to biology at the moment. I hope I live to an age where I'll be able to gain an understanding, or other people will gain an understanding, and I'll be able to read about it. But maybe not. It's possibly one of the huge intractable problems in biology. But it's largely irrelevant to this discussion, since we're looking at a photograph. We're not dealing with what the eye perceives. We're looking at a photograph and we're making a particular measurement based on geometry that is testable. And I've tested what images a camera captures on a flat and level surface. Again, see the photos of the hurdles in my video. These tests confirm that if the Earth was flat, the mountains in the distance should always appear well above the line drawn across the photo, level with the top of the Houghton Monument. This is just a fact of geometry. I've tested it several times using various cameras and methods. It's really not in dispute unless you can show a demonstration where which produces some kind of different effect. But what I've done on the hurdles there, that works every time I do it, in every circumstance I do it, on a flat level surface. So given those facts, there is only one reasonable conclusion to draw, and that is that the Earth is not flat. The fact that the observation matches spherical Earth predictions really well means that there's also no reason to think that the spherical Earth model, which matches all other predictions and observations, or all other predictions match the real world observations, there's no reason to reject the spherical Earth model. But this one photograph all by itself is enough for us to reject the flat Earth idea. Now, you have said that you want to see evidence that falsifies the flat Earth hypothesis. This is that evidence, and there's loads more. I've presented you with that evidence, but your attempts to claim that this observation is possible on a flat Earth surface are full of errors, and you show zero regard for the actual sizes and distances involved. You, Gleem, have a simple choice. You can either accept that this photo and dozens of others that have been presented by various other YouTubers demonstrate that Earth cannot be flat. So here I'm thinking about Soundly's pictures of the power lines, of Pontchartrain Causeway, of the Little Tensas Bayou. I'm thinking of demonstrations, pictures by Wolfie. I'm thinking of the Mount St. Helens and Mount Rainier or whatever it's called in the States. I'm thinking about ones that Where's Wally has posted, Too Many Hits has posted, and many, many other pictures. These all demonstrate that Earth cannot possibly be flat. My own work I call it work, it's hobby, at East Lothian, at Traprainlaw and the Hopetoun Monument, I came up with 9 or 10 different demonstrations that the Earth cannot be flat from that one location. So you either have to accept that the Earth is not flat, accept the evidence that you've been presented with and which you've requested, or come up with a real explanation using correct numbers, real math or geometry and scale diagrams to show how it is possible on a flat Earth. And once you've dealt, if you could manage to deal with the one observation that I've asked you to deal with, which is the hills and the Hopetoun Monument, the very first observation that started this whole video off. So if you could explain this in terms of a flat Earth, I honestly don't think you can. I think it would be highly unlikely, but I remain open to the possibility that there may be an explanation, a flat Earth explanation for this. But once you've come up with that flat Earth explanation, can you then apply that same flat Earth explanation to why Lake Pontchartrain pictures look the way they do, or the Little Tenses Bayou pictures look the way they do, or my observations of the Isle of May look the way it does? I think Too Many Hits has done a similar one of the Isle of May. I'm going to be doing another one of the Isle of May hopefully in December, which might be a real cracker. You then have to use that same geometry, that same math, that same explanation of how light behaves and how the atmosphere behaves, or whatever it is you use, to explain all of these observations. And if you can do that, and if that actually works, then we have a situation where there are two competing models for the shape of the Earth, and we can say that the evidence for both is equally strong in terms of observations made by lay people on YouTube. Of course, then we go on to look at things like apparent rotation of stars about celestial poles being different in the northern and southern hemisphere, and a whole range of other factors that back up the spherical Earth model and don't, in my opinion, cannot be explained on a flat Earth either. So there you go, Gleem. You've been presented with the evidence you asked for. You either have to accept that evidence, or you have to come up with an alternative explanation that actually works using the data, your figures that you are presented with. I bet this is the longest video I've ever produced. I may chop it up into smaller bits to actually post on YouTube. We'll see once I've saved everything. If you've managed to make it to the end, thank you for watching. I somehow doubt that Gleem will have got past the first 2 or 3 minutes, but I live in hope. Cheerio.